In this video, we're going to look at the topic solving exponential and logarithmic equations, and we're going to go through 3 examples. So the first example we're going to go through is e to the 4x minus 5 power minus 7 is equal to 11,243. So in order to solve exponential and logarithmic equations, we need to have, in this example, our exponential by itself. So notice we have that minus 7 in the way, so I'm going to go ahead and add 7 to both sides. And I get e to the 4x minus 5 is equal to 11,250. And now that I have my exponential by itself, we have to use those inverses in order to get rid of an exponential. So remember that our inverse of e to the x is the natural log of x. So what I'm going to do is I'm going to take the natural log of both sides. So the natural log of e to the 4x minus 5 is equal to the natural log of 11,250. What the natural log does is it cancels out that exponential. So now all we're left with is that exponent that gets brought down. So 4x minus 5 is equal to the natural log of 11,250. Okay. Then we're just solving for x. So I'm going to add 5. So I have 4x is equal to the natural log of 11,250 plus 5. And then I'm going to divide both sides by 4. And I get x is equal to the natural log of 11,250 plus 5 divided by 4. So I can type that into my calculator, and I will get a decimal answer. So first let me do that natural log of 250. Okay, then I'm going to add 5 and then divide by 4. So I get x is approximately 3.58. Okay, so these are both answers. One is leaving it in natural log form and one is turning it into a decimal. Either one would be acceptable. Okay, let's look at the next example. Example 2. Again, we have another exponential function. And notice that this exponential function is already by itself. So it only has e and then our exponent. There's nothing being added or subtracted to it. So that means our first step here to get rid of that e is to take the natural log of both sides. So I'm going to do the natural log of e to the 1 minus 8x is equal to the natural log of 7,957. Remember, the natural log cancels out the exponential function. So these cancel, and then that exponent gets brought down. So 1 minus 8x is equal to the natural log of 7,957. And then we're just solving for x. So I'm going to subtract 1, and I get negative 8x is equal to the natural log of 7,957 minus 1. And then I'm going to divide both sides by negative 8. And I get x is equal to the natural log of 7,957 minus 1 over negative 8. And I can type that into my calculator to get an approximate. So let's see, 7,957, take the natural log, subtract 1, divide by negative 8. So I get approximately negative 0.998. So again, these are both the answers. One's in decimals form and one is leaving it in exact form with the natural log. Okay, last example here. In this example, instead of exponential equation, now we have a logarithm equation. Okay. So the only difference with the logarithm equation versus the exponential is that we have to use a different inverse. So remember that the inverse of log of x is 10 to the x. Okay. So for this problem, we first check that our logarithm is by itself, which it is. Notice that it's log and then in parentheses, that's what the log is of, but there's nothing after that parentheses. There's no adding, there's no subtracting part of it, so we don't need to move anything over before we start. Okay, so we're going to go ahead and apply that 10 to the x inverse to this problem. So we're going to write 10, and then everything we write after is an exponent. So log of 2x plus 5 is equal to 10, and then that 2 is our exponent. So what the... Okay, thank you. Throw in the trash, please. The 10 and the log cancel out. So I'm left with 2x plus 5 is equal to 10 squared. We know that 10 squared is 100, so 2x plus 5 is equal to 100. And then we just solve for x. So I'm going to subtract 5, and I get 2x is equal to 95. And then divide by 2, I get x is equal to 47.5. So that is my answer. So notice the only difference is that if we have an exponential, we cancel it out with the inverse of natural log of x. If we have a logarithm, we cancel it out using an inverse of 10 to the x power. And the opposite is true. So just like 10 to the x power is the inverse of log of x is the inverse of 10 to the x power. And the same is true for the exponential and natural log function.